Hi there, as a part of AgilePoint's version 10 release, we're happy to announce support for AgileLLM. Now, if you haven't heard that name before, it's an AgilePoint provided large language model primarily for evaluation customers. So if you're trialing the cloud product, would like to test the AI features, and don't yet have an AI subscription, this is for you. Now, over the course of this video, we'll walk through the various control tower activities available for AgileLLM as a part of a sample application. Okay, now like many other AI platforms, AgileLLM has both inline process activities, which we've covered in our companion video. And our focus for this video is going to be the various control towers. Now what you're seeing here from a control tower perspective are essentially a couple of high-level categories. We have Analyze Image, which leverages computer vision, and Chat Completion, essentially the typical text-based interaction you've probably already had with various large language models. But across each of them, we have a number of ways to bring in dynamic process behavior. For example, under Analyze Image, you'll see the ability to adapt the flow, inject ad hoc tasks, initiate dynamic subprocesses, and send notifications. Now the same is true here from a chat completion perspective. And as you're seeing, we have standalone control towers for both chat completion and Analyze an Image. Now we're going to see both of these control towers leveraged as a part of this application. But let's go ahead and walk through our sample app. So the use case for today is going to be an insurance claim application. The process will start with an insurance customer having an accident and calling into the call center to relay initial details. From there, the process flows externally back to the customer, where they'll provide a more detailed narrative around the accident and supply images showing damage to the vehicle. Now from there, there's a number of additional steps that we won't cover as a part of this video. But let's go ahead and touch on the various control towers that you're seeing here across the top. Now first we have an image classification agent. This agent is in charge of analyzing the customer provided image showing damage to the vehicle and will hand its insights over to our claims agent. So the claims agent will essentially make a comparison. How well does the output of our image classifier line up with the customer provided narrative around the accident, looking for inconsistencies and so on. And our claims agent and image classifier will hand their insights over to our final fraud predictive agent, essentially looking at the claim as a whole. How likely is it that fraud is present in this claim? Now, in the event that fraud is likely, we're going to see the typical processing paused, and additional levels of review will be dynamically injected into this claim that we don't have here at design time. So now that we understand the role that each agent plays in uncovering fraud in this claim, let's look at the configuration. Okay, let's get started with our image classification agent. So as you're seeing here, this is using Analyze Image, so no dynamic process behavior, just the response back from our vision model. Now that image will be provided by the customer during the customer engagement step, so uploaded to the form and moved into one of the out-of-the-box repositories. In my case here, I'm using Box. Now, as far as the model configuration is concerned, no access token required. This is an AgilePoint native feature, though I do have the option to set model parameters. And moving into the system instructions. So the overall goal is to analyze the image as provided by the customer, showing damage to their vehicle, and to return a structured damage assessment. Now, the skills include computer vision, damage detection, JSON formatting, rules-based decisioning, things of that nature. The input is going to be the single image as provided by the customer and various instructions. So here you're seeing that structured damage assessment that we're interested in. In other words, there are 9 distinct parts of the vehicle where we need a damage assessment. And basically to make the decision based on what's shown in the image, no assumptions or anything of that nature. Quality verification, basically ensuring we follow a sequence of steps. 9 distinct parts of the vehicle must be reported on. The value is yes or no, things of that nature. And then the output here being a JSON structure, right? And I've provided a sample response. Okay, now our triggering event. This will be when the customer engagement step has been completed, but again, can bring in additional filters here. The request is blank at this point, right? That's coming from the form and moved into our repository. The response is that structured damage assessment that we've talked about. So you're seeing here the 9 parts of the vehicle that we're interested in. and we've mapped that back to our application. No parsing required in this case. If I had stored the response in a variable and I wanted to parse out certain elements, different ways I can do that here. And then the actions. Again, blank here. We just want the response from our model. Now the final two agents, the claim analyzer agent and the fraud predictive agent, work very similarly. The fraud predictive agent does have dynamic behavior, so let's walk through that one. So again, no access token required. Moving into the system instructions. Here we're looking at the totality of the claim, right, to make a fraud assessment. So we're looking for anomalies, inconsistencies, unusual patterns, and various risk factors. The skills include insurance domain understanding, fraud pattern detection and analysis, rules-based reasoning, and clear explainable decision making. Now the input here is again that JSON structure. Most of these details here coming from the policy itself. Various instructions, quality verification, and then the output here being a JSON structure where we want the fraud prediction and probability. Triggering event here will be when the wait for milestone activity is completed. The request has been intelligently brought over from my system instructions, so that same JSON structure that we showed earlier. And you're seeing that here being mapped. Now the response from our model is going to be a fraud prediction and a probability. So we're mapping that back from the model to my AgilePoint application. Again, no parsing is going to be required. And then the actions. So here's where we want to bring in some guardrails and constraints around how and when AI is impacting our process when fraud is likely. So in the event that fraud is found, we're going to dynamically inject additional levels of review. You're seeing that sub-process specified here, though this could be a variable. And then some rules. So this will only be invoked when the fraud prediction is equal to true and the probability is greater than 50%, or maybe the report itself was fraudulent, right? In other words, not reported by a human, perhaps by a large language model, or when key conflicts exist, such as differences between what's shown in the image and the customer provided description of how they had that accident. So now that we understand the configuration of our various activities, let's go ahead and run it. Okay, so a customer has just had an accident. They've called into the call center, and our call center employee is now capturing initial details about that accident. So starting with the policy ID, we can select the vehicle involved in the accident and the driver's name. We'll capture initial details. Recall that a more detailed narrative will be provided during the next step. The third party that was involved, the prior claim history, and lastly, we'll leave a comment and open up our new claim. All right, so our application is just kicked off here. Let's go ahead and track it. The next step will be with the customer engagement. The next step will be customer engagement, where we'll provide more details about the accident. Okay, so playing the role of the customer, I've just received an email with all of the details of my claim, and I have a task here to provide more information. Okay, so up top, we're going to upload an image showing the damage to the car. So you're seeing that image here showing clear damage to the front of our vehicle. So let me upload that. Now, while this is uploading, there's an additional narrative that needs to be provided down below. So what I'd like to do is show some pretty clear conflict between what's shown in the image and the accident description. So here, instead of the front, I'm going to indicate that the back of the vehicle was damaged. Now moving back into our process tracker, we're going to see indicators for our various agents once they're invoked. Okay, so all three of our AI control towers have now been invoked, and as you're seeing here, the typical next step would be with the claims handler. But in this case, fraud is likely, so the typical processing has been paused. In fact, if I try to open this up, I'll be met with a warning indicating that fraud is likely in this claim, and as such, the typical process has been paused. So as you're seeing here, we have a pretty high level of certainty that fraud has occurred in this claim, so this task won't be available until our exception has been handled. So if I go back into my task list and refresh things, you'll see here I have a fraud alert. So this alert has been dynamically raised to a subject matter expert, again, because fraud is likely in this claim. And as you're seeing here, the control tower is suggesting we make an ad hoc insertion for additional levels of review. So in this case, the control tower is operating with a human in the loop, but bear in mind that once enough trust has been developed, these actions can be taken autonomously. So I'll accept that suggestion. I'll inject another task for myself, and I'd like to keep the lock on all of the downstream steps. So now yet another level of review is being dynamically injected behind the scenes by the AgilePoint engine. In fact, if I refresh my task list, we'll see that task sitting in my bucket. Okay, so here it is. So now I'm playing the role of the fraud investigator. All of the insights uncovered by AI are now visible to me. So here we're seeing the findings from our vision agent indicating damage to the front of the vehicle. Our claims analyzer agent has identified that this is in fact a human authentic report. In other words, it was not written by a large language model. However, there are key conflicts between the accident narrative and what was shown in the image. So here, using all of these insights and my domain experience as an investigator, I'll take a final action to validate the fire and police reports, and then we can determine how to move this claim forward. Now, I could reject the claim, but in my case, I suspect this is just a customer who's a bit frazzled after having had an accident. Okay, now just before we close the video, I do want to highlight the different ways by which we can understand how and why an AI agent has taken an action against our application. So from a visual audit trail perspective, in the process viewer, there's a capability here called the Adaptive Orchestration Monitor. So as you're seeing here, we have all of the input, output parameters, and the action that was taken by our control tower agent. So in addition to a visual audit trail, AgilePoint also maintains this on a textual basis as well. So here I have the instance up in the Manage Center, and you'll notice we have a tab for AI control towers, where again, similarly, all of the input, output parameters, why an agent took action, and the action that it took is all being recorded here. Very handy from an ongoing audit perspective, and of course, for ongoing model retraining. Okay, so with that, that's going to conclude the content for this video. Thank you so much for watching. Until next time.